So we're going to start matrices, which a matrix is basically a way to organize information, a lot like a table. They have a dimension or a size that's defined as the number of rows by the number of columns. So for example, in this one down here that I'm highlighting, it has 3 rows and 2 columns. So it is a matrix of dimension or size 3 by 2. That's going to be important later to know how to label and define your dimensions. So if you look at a pair of matrices that are supposed to be equal to each other, it's important to know that matrices can only be equal if they have the exact same dimensions. Because if they're equal to each other, that means the elements in the same location in your matrix are the same value. So like here, I know x plus 2 has to be equal to -3. And then the ones in the lower left-hand corner, z plus 3, has to be equal to 4. And I also know that my bottom right-hand corners, y minus 1, has to equal 5. The upper right-hand corners have to be equal as well, but you can kind of already see those are. So those are just numbers, and 4 is equal to 4. So to solve this, we're just going to solve those 3 equations, and those will give us the values that will make our elements in the same location equal. If you have matrices that are different dimensions, like in part B here, it's actually not possible for them to be equal to each other. You have a 2 by 2 matrix and then a 3 by 2 matrix. And if I start setting things equal to each other, I run out of any values for my bottom row on my matrix on the right-hand side of my equation to be equal to, because they're not the same size. So this one has no solution. Matrices can have operations performed on them, like addition, subtraction, and multiplication. So to add or subtract, they have to have the same dimensions and be the same size, because you just do the operation with the elements in the same location, like I need to do for minus 4 square root 3 minus 2 square root 3. I actually think I'm going to go ahead and multiply my -1 in there and change all my signs first, though. Then I'd have to do each one that's in the same location to make my new matrix. So -2 plus 4 gives me 2. 1 plus 3 is going to give me 4. And then in my second column, number 2 there, I get 3, 0, and 4. You can have your matrices represented with letters, like instead of just rewriting the numbers every time, you can say, hey, find 3a minus b. So I'm going to write it with my values for matrices A and B plugged in here. And then follow order of operations. You multiply before you add or subtract. If you're multiplying a constant times a matrix like that 3, you just multiply every number inside times it. It's different than multiplying 2 matrices together, which we'll talk about in a second. And then just like before, to do my subtraction, I'm going to go ahead and choose to multiply my -1 in, and then just add everything that's in the same location together to get my new matrix. Multiplying matrices times one another is probably not defined as you would expect it to be. In order for it to actually work, the first thing you have to make sure is the number of columns in matrix A has to be the same as the number of rows in matrix B in order to be able to multiply. So say I wanted to multiply these 2 matrices together, and those are their dimensions. I would need to check that the number of columns in matrix A matches the number of rows in matrix B if I'm going to multiply and get AB, and they do, so it is possible. The dimensions of my new matrix AB for my product are going to be my outer dimensions there. It's going to be a 3 by 2 matrix. If you look at B, the number of columns in matrix A doesn't match the number of rows in matrix B, so it's not possible to do that matrix multiplication. So why does it have to have those dimensions? You'll kind of see whenever we go ahead and multiply here. So yes, I can multiply these 2 together. My new matrix is also going to be a 2 by 2 matrix from my outer dimensions. So I kind of like to label things here. I'm going to label some rows and columns as that's row 1, row 2, and then in my second matrix, column 1 and column 2, and then in my new matrix, my rows and columns. Okay, so say that I want to find the value of the element in the upper left-hand corner. That's in row 1 and column 1. So I'm going to multiply row 1 and column 1 together in kind of a strangish way. but you multiply the first thing in row 1, 2 times the first thing in column 1, 1, and then you move over in row 1 to get to the next element and down in column 1 to get to the next element. So you're multiplying -3 by +3, and then you're going to add the result together. If I move down and I want the element in row 2 in column 1, I'm going to multiply row 2 times column 1 in the same way. First element in row 2, first element in column 1, and then second element in row 2, second element in column 1. Add them together. If I want the element in the upper right here, I'm going to use, since that's in row 1 in column 2, I'm going to use row 1 in column 2 and multiply 2 times -4, and then -3 times -2, and then add that result together. And then for my last element that is in row 2 and column 2, I'm going to multiply row 2 by column 2. 1 times -4 plus 5 times -2. And then just simplifying. So you're going to end up with 2 minus 9, 1 plus 15, -8 plus -6, 4 plus -10, and then that for your final result. Let's look at another one. Again, make sure it's possible first. This is a 2 by 3 matrix multiplied by a 3 by 1 matrix. And then our new matrix is then going to have dimensions 2 by 1 since they match and it's possible. So I'm going to have 2 rows and only a single column here from this matrix multiplication. So my result's just going to have those dimensions. And when I multiply things together here, that means to get my element in row 1 and column 1, I'll be performing 3 multiplications. 2 times 2 gets me 4, 3 times 1 gets me 3, and 1 times 4 gets me 4, and then adding those results together. And then if I'm in row 2, I'll be multiplying 4 times 2, and then -3 times 1, and -3 times 4, and adding those results together. So you're going to end up with just a matrix that contains 11 and 5.